All right, we are lesson 4.6a. Okay. Essential standard. I can factor polynomial expressions with standard factoring techniques. You have learned in the past and used greatest common factor. We have to factor that out. You have learned difference of squares. We still have to use it. I am not sure if you've learned sum or difference of cubes, but if so, it'll be somewhat of a review. Trinomial factoring, which you've done before, and factoring by grouping, which I believe is new. So then the next thing will be I can solve once you have factored them. That'll be the next lesson. So the first step, always find the greatest common factor. If you have an X in common or a 2 in common or a 3 in common, you need to make your life easier and pull it out. That is the first step. The second step is to look for a pattern. Okay, this is all about patterns. Okay, so our first pattern is two terms. So if I have a two-term expression in your polynomial, then we are looking for either difference of squares pattern, sum of two cubes pattern, or difference of two cubes pattern. So let's talk about the difference of squares. You've seen this before. If I have two numbers that are subtracted from one another and they're squared, then they factor into a minus b times a plus b. An example of that would be x squared minus 4. That factors in x minus 2 times x plus 2. You have worked with those, you should know those. Difference or sum of two cubes and difference of two cubes. So we have a situation where I have a cubed plus b cubed or a cubed minus b cubed. So two terms, both of the terms are cubed expressions. They will factor into the following pattern. Okay, the a plus b cubed, when they're both cubed, you take the a and the b and you add it together. So the signs are the same, a plus b. Then you square a and you square b and you have that at the end in the beginning, and then you switch the signs and multiply times ab. Then notice if it's the difference of two cubes, I have a minus b. So the sign in that situation is identical to where I started. Then I have a squared, I have b squared, and I have switched the center sign. So this is the only thing that I kind of have, think about. If I start off with a cubed plus b cubed, I'm going to have a plus b. And then the only thing I need to worry about is the switching of the signs in the middle. Okay. All right, let's see what that might look like. What if I had x cubed plus 8? That is the same as x cubed plus 2 cubed. Those are the sum of 2 cubed. So x plus 2 times x squared, switch the signs, 2x plus 4. Okay. And then I could do the same thing with the difference of cubes. So those are the two term patterns. The difference of squares, the sum, and difference of two cubes. Then we have three terms, and you should be familiar with this. You're looking for two numbers that multiply to c, and that's in the case where there's no coefficient in front of x squared, and then they add up to b. Okay, you have done this many times. The next one is when I don't have a coefficient that's 1, I have to look for two numbers that multiply to the product of a times c, and then add to b. So you have done those before. This might be new. And this is when we have a factoring by grouping. We have 4 terms. The first thing I do is I take these first 2 terms and I look to see if I have anything in common. And sure enough, I do. I pull out my x and I get left with a plus b. Then I look at my second terms, last 2 terms. We have 4 terms, and notice I have a y in common, and I pull out my y. There's my y, and what am I left with? I'm left with a plus b. Notice that the a plus b in parentheses is identical. That's what you're looking for. You're trying to create something in parentheses that is identical and such that you can now factor out those, pull that out, and what are you left with? You're left with x plus y. And so this is the answer, okay? The whole point is to get that item in parentheses to be identical so that you can factor it out of the expression. In my opinion, those can get very tricky, and I do believe he's been quite kind in how he lays those out. There is such a thing as prime polynomials where we can't factor them, okay? All right, those are hard to identify because you're constantly trying to figure out what am I missing. All right, 8x cubed minus 27. Notice the exponent is some type of multiple of 3. That should be a hint that I'm looking for cubes. And sure enough, that is the same as 2x cubed minus 3 cubed. So a is equal to 2x. B is equal to 3. Now I have to use my difference of cubes pattern. So it'll be a minus b. So a minus b times a squared. Switch the signs, ab, and then plus b squared. Okay. All right. So what is a minus b? That'll be 2x minus 3. A squared is 4x squared minus a times b. So that's 6x plus b squared, which will give me, I'm sorry, I did not switch the signs there. That should have been positive 6x, and then plus b squared is 9, and there's your answer. All right, how about this one? Notice in b, it's x to the 4th. That's an even number, definitely not a multiple of 3, should give you an indication that it's probably going to be squares. So x squared squared minus 9 squared. So it's the difference of 2 squares. And so I have x squared minus 9 times x squared plus 9. I'm not done yet, and this happens quite often because x squared minus 9 is another difference of difference of squares. That is the same as x minus 3 times x plus 3. X squared plus 9 does not factor, so we are done. And this right here was broken down into this portion right there. So just because you've done one step doesn't mean you're done. You got to keep asking yourself, is it another pattern? How about C? In C, the first thing remember we're supposed to do is to check for greatest common factors. And I have a 3 in common. So 24 has a 3 that I can factor out, and 3 has a 3. In addition, I can factor out a y. So I'm going to factor out 3y, and I'm left with 8x to the 6 plus y cubed. Is that right? Yes. Okay, yeah. Oh, there was one thing I forgot to mention. I'm going to mention it now. When you have a difference of cubes or a sum of 2 cubes, once you factor it, this term that you get, it does not factor. Don't sit there and try to figure out what multiplies to 9 and adds to 6. It will not factor. Okay. Okay, back to where we were on C. I pulled out a 3, I pulled out a y, I'm left with 8x to the 6 plus y cubed. Notice 6 is a multiple of 3, so it's probably a cubed, and sure enough it is. That is the same as 2x squared, which is cubed, plus y cubed. So, because I have x squared and I've cubed it, basically I have to multiply those exponents, right? So that becomes x to the 6, and then 2 cubed is 8. 2 times 2 is 4. 4 times 2 is 8. So we're continuing on. So we know that a is equal to 2x squared. B is equal to y. Now I have to do my pattern. So I still have my 3y. Now I have a, which is 2x squared, and plus b, which is y. And then I have a squared, which will be 4x to the fourth. Switch the signs, and I will get 2x squared y when I multiply a times b. And then I have plus b squared, which is y squared. Now, this is the section. You do not need to worry about trying to figure out how this factors because it will not factor, okay? You would have to use quadratic equation. And so whenever you have a difference of cubes or the sum of cubes, you can rest assured that you're done once you've gotten to that point, okay? And so a lot of times I would spend time trying to figure out if things factor or not. Okay, your turn. Welcome back. So first thing we need to do is remove an x because we have an x in common. So we got x cubed plus 8y cubed. Now you should think to yourself, I think I have a sum of cubes, and I do. So a is equal to x, b is equal to 2y, okay? 2y cubed is 8y cubed. So now I'm just going to do my sum of cubes. So I have x plus 2y, and then I have a squared, which is x squared. Switch the sign, so minus 2xy, that's a times b, plus b squared, so 4y squared. Am I done is the question. We know for a fact that this won't factor anymore, and yes, I am done. So all right, now E, we have x to the fourth minus 9x squared plus 20. And what we have here is we have a squared minus 9a plus 20. And what a is equal to is x squared. This is a quadratic, but not in terms of x. It's a quadratic in terms of x squared. So we will find and approach it just like we would anything else. We, in the past, we will find two numbers that multiply to 20 and add to -9. So add to -9, and that will be, let's see, -10 times, hold on, what are they? Oh, 4 times 5. I'm sorry, multiply to +20, add to -9. I lost my train of thought there for a minute. And sure enough, that's -4 and -5. But again, it's not quadratic upon x, it's quadratic with respect to x squared. So x squared minus 5 minus 4, okay? And so the question is, am I done? Well, notice that x squared minus 4 is a difference of 2 squares. So I have to continue with the process. That'll give me x minus 2 times x plus 2. And that is this portion right here. Okay, now I am done. Okay, because x squared minus 5 does not factor. All right, you try one yourself. Welcome back. This is, again, the pattern of, it is quadratic, but it's not quadratic with respect to x. It's quadratic with respect to x squared. And so we will factor that. We are trying to find two numbers that multiply to -9. So multiply to -9 and add to a -8. So we got to get add to -8. And we will find that to be -9 and a +1, except, and again, it is quadratic around x squared, not x. Okay, so now I have another item that I must factor. This is a difference of 2 squares, so that becomes x minus 3 and x plus 3. And then I have x squared plus 1, and that does not factor. All right, now we're into 4 terms. So 4 terms, we know that we are going to have a factor by grouping. The first thing we need to do we have a common greatest common factor? And sure enough, I do. Look at every single one of those terms has a y in it. I can actually pull out a y squared. So we're going to factor out a y squared and not equals times y to the cube plus 4y squared plus 3y plus 12. So if I divide y squared out of each one of those, that's what I'm left with. Now I have to focus on, let's focus on the first 2 terms, and let's, again, he has been very kind. The ones I had to do were very difficult. So the thing I have in common in the first 2 terms is a y squared. So factor out a y squared, you're left with y plus 4. And then we're going to do the same thing on the next 2 terms. And what do we have in common in the next 2 terms? I have a 3 in common. So I can factor out a 3 and I get y plus 4. Okay, and so that gives me this, and that gave me this. Okay, now notice I have y plus 4 in those parentheses. That's the same. That's fantastic. So I can factor that out. And what do I get left? What's left? I'm left with y squared plus 3, and then I have my y plus 4. Okay, now, is there anything else I can do? Is there any difference of cubes or difference of squares? And the answer is no. And so this is the answer. All right, try one yourself. There was no greatest common multiple, but I'm going to focus on the first 2 terms. And based on those first 2 terms, I can pull out an x squared. So I pulled out an x squared, and I'm left with x minus 4. Then I'm going to focus on the next 2 terms. And what is in common is a -9. I'm going to explain why I need to pull out a -9. -9, I'm going to pull out that and I get x minus 4. Now, the reason why I pulled out a -9 is if I would have pulled out a +9, and so let's assume I did that. So 9, it would become -x plus 4. Notice that I'm really close in that situation to what I want, which is to have an x minus 4, and that should trigger you that you should pull out a negative number instead of the positive, so you can force that term inside the parentheses to be identical to the one that we just had, okay? And so now once I've done that, I can factor this out, and I get x squared minus 9 times x minus 4. Now, notice the x squared minus 9 is a difference of 2 cubes. I'm sorry, difference of squares. And so that factors into x minus 3 times x plus 3. X minus 4 does not factor any further. And so this is my answer. And this came from the difference of 2 squares. Okay. All right, moving on. We have, first, I should see that I have a 2 in common and I have an a squared. So I need to pull out a 2a squared, which will leave me with a to the 4th minus 2a squared minus 8th. So if I divide out 2a squared, then another way to check 2 is if you multiply 2a squared times a to the 4th, I get 2a to the 6th, and so forth and so forth. So you can double check your, when you pull out your greatest common factor. Now I'm going to need to focus on what's inside the parentheses. And again, this is that situation where I have a squared minus 2a minus 8, where a is equal to a squared. And so I need to find 2 numbers that multiply to -8 and add to -2. And that would be -4 and 2. So I get a squared because it's quadratic over a squared, not just a. And then I get a squared plus 2. And I still have my 2a squared. Notice This is a difference of two squares. So I am not done factoring. A minus 2 times a plus 2, and then a squared plus 2 doesn't factor anymore. And I'm done at this point. That's where I got that from. And your answer is as follows. Okay. All right, welcome back. After doing J, your turn. Here is how this will work. The first thing we see is that we have a W that is in common, and we can pull a W out. So we will divide each term by W, and we will get W to the 4th power minus 17W squared plus 16. Now notice that I now have a quadratic, 3 terms. I have 3 terms, and it is not quadratic with respect to W, it's quadratic with respect to W squared. So you can look at it as W squared minus 17W squared plus 16, and we will factor it just like we would any with the same type of approach. When we have 3 terms, we look for a number that multiplies to a positive 16 and adds to a negative 17. So we need to add to a negative 17. And when you factor that, you will find that negative 16 and negative 1 multiply to a positive 16 and add to 17 or negative 17. Okay, and so it is, oops, not x, it is W squared because it is a quadratic polynomial with respect to W squared. And we are going to continue with our process because we should notice that this is a difference of 2 squares. So we will factor that. It's 2 terms, and that will be W minus 4 times W plus 4. And people don't recognize this, but this is also a difference of 2 squares, and that will be W times negative 1 and W times positive 1, and then we have W on the outside. And this is our answer. So a lot of times we forget about 1 being a square, but it is a square. So, all right, so that is the end of our lesson today. The message or the takeaway from this lesson is to look for patterns. So let's just review our patterns. We have, if it's 2 terms, we're looking for either the difference of squares or the sum or difference of cubes, okay? And I believe I got the impression that actually those equations would be given to you on your test. I have to confirm that, but I will definitely confirm that. And then 3 terms, we have practiced that before with a 1 as the coefficient in front of our x squared term, or with a value a, an integer in front of x squared. Okay, and then the factor by grouping. So if you have 4 terms, then we're going to factor by grouping, and the goal is to create in parentheses an expression that is identical to one another, so you can then factor that out. Okay, so we're looking for patterns. That is the way we factor these types of polynomials. All right, message me if you have any questions.